Okay, these are notes reviewing the geometric and binomial distribution. And first off, I want to remind you that the geometric and binomial are both Bernoulli. In other words, they have exactly two possible outcomes, which can be a success or a failure. In every situation, the probability is constant and trials are independent. So basically, really important to keep in mind that success and failure are the only possible outcomes. Trials are independent. Probability remains constant. It's also a discrete probability distribution. In other words, the successes and failures are countable. You can have 0 successes, 1, 2, 3, etc. So the geometric, as I said, is a discrete probability distribution, and it represents the number of failures until you get to the first success. All right. So geometric is qualified as the first success. The formula is basically 1 minus p, which is the failure, p being probability, and n minus 1. So basically, this is your formula. All right. Sometimes we like to say it's q to the n minus 1 times p, but essentially that's the formula, but that's just for kind of extra information. One of the things you do need to know is the mean or the expected value formula is 1 over p. You don't have to memorize that, but you need to know where to find it. You also need to know where to find the variance and the standard deviation. And in this review, I'm not going to talk about variance and standard deviation, but you do need to know where these are as a resource. We will be referring back to this. Identifying a geometric. Fixed probability, trials are independent, and once again, looking for that first success. So the key word is first. Now, determining whether something is a PDF or a CDF is usually a little bit of an issue for people. So the probability of the first success will be on a specific trial tells me it's a PDF. It has to occur exactly on the third person or exactly on the seventh thing. If it's specifically the third, specifically the seventh, specifically some value, we're working with a PDF. Whereas a CDF means that the first success could occur among the first 7. It means it could be the first one, the third one, the fourth, fifth, sixth, or seventh. It could occur anytime. So anytime you have multiple values, it's a CDF. All right. But once again, the key word tell you that it's a geometric is first, and these are your keywords to let you know whether or not it is a CDF. All right. So here's your keywords to let you know if it's a CDF. All right. 1 minus geometric CDF, not very likely to happen, but among, before, etc., kind of lets you know that it's a CDF, and then you're looking at the word at least. But probably not going to happen, so I'm not going to worry too much about this. You can probably cross that out and ignore that. Geometric expected values you do need to know, right? So this is going to be really important. Use when the question is asking, when would you expect the first? So when I have first and expect together, probably going to be using a geometric expected value formula, which is once again 1 over p. So I'm going to write that down right here. So mu equals 1 over p, or the expected value is that. All right. So anytime you have expect and first, probably going to be needing to use that formula. All right, so that's an overview of what the geometric is, and we'll put it to work in just a moment, but I'm going to go through the binomial, and then we will combine those two problem sets together. So binomial distribution is also a discrete probability distribution, but instead of looking for the first, we have a certain number of successes to get, so you have a specific number of trials. Right, you have a specific number of attempts. With a geometric, technically, I may never have my first success. All right, I might be always looking for that first love of my life. That first love of my life may never happen. Whereas with a binomial, it's like, hey, out of 10 people, how many people did you end up liking? All right, and I had a specific number of trials. I had a trial of 10. This is my formula. I'm just going to tell you what it means. You don't really have to know how to use it for this class. This right here is my number of trials. This right here is my number of success. Probability of success raised to the number of successes. This is the probability of failure. It was 1 minus p. And basically all I did was take the number of attempts minus the number of successes. All right? The mean, really important that you be able to use that. And the mean of a binomial, or the expected value of the binomials in P. We're not going to be going over these two things today. You just need to know where to find those. All right, a binomial PDF. First off, how do you identify? With a geometric, it was the first. Generally speaking, they're either going to make it a certain number of trials or attempts, or out of, or attempts are pretty much your keywords. All right, those are what you're looking for to kind of identify. So when you use a PDF, use when the problem has a fixed probability and a set number of trials and is asking for it to happen on a specific number of successes. Must be a specific number of successes, not a range of values. What's the probability that it happens 7 times out of 10? Well, 7 is a specific value, therefore PDF. What's the probability it happens 0 times out of 100? 0 is a specific value, it's a PDF. It has to be an exact singular value, not multiple values. Whereas on a binomial CDF, we're asking for a range of values. And these are the key words that let you know you're looking for a range of values. If you have those, you're like, hey, we're looking for more than one value. In other words, less than 3. Oh, well, that means it could be 0, 1, and 2. That's multiple values. More than 3. All right? So anytime it's multiple values, you're looking for a CDF, once again, a specific number of trials. For the 1 minus situation, anytime it's 1 minus, it's going to be a CD. First off, 1 minus will always be a CDF, and these are the key words that let you know that it's 1 minus, all right? And generally speaking, if 0 is not included, if you're doing a CDF and 0 is not included, it's going to be 1 minus. Binomial expected. Usually when the question is asking how many successes do you expect from a set number of trials? So basically the set number of trials tells me it's a binomial. The word expect lets me know that it's the expected value, which means I need to use the expected value formula. Now, real quickly, I recognize that I went through this entire page of things, and that's kind of confusing. But I think it gets very, very straightened out once we actually get to the problems. So I'm going to drop down to the scenario. And the scenario says this. The study is being performed to determine whether or not people who have had COVID-19 are now immune to the virus. To determine whether or not a person that has had COVID-19, epidemiologists are randomly selected people from New York City and testing their blood to determine whether or not they have the COVID-19 bodies in their system. If they have the antibodies in their system, they are placed in the study. It is known that 21% of the residents of the city have COVID-19 and have antibodies in their system. By the way, that's pretty accurate and a pretty current value. So this is kind of real world here. So in a group of 30 people, so we have a group of 30, how many would you expect? Because I have a group, this gives me a hint that I'm probably talking about a binomial. But this tells me it's a binomial expected because I have, so here's my group, so a group of 30 expected. So this is the expected value of a binomial. And on the front sheet, we said that that was in P. Well, we know our probability is 21. So the expected value is going to be 30 times 0.21. And when I do that with my quick math that I have on another screen, I find out that it's 6.3. So my answer is 6.3. how many would you expect to test until you find the first? All right, so once again, we know that we're dealing with an expected value because it says expect, but they say first. So first tells me this is a geo. This tells me it's expected, so I need the expected value of a geo, which is going to be expected is 1 over p, all right, which in this case is going to be 1 over 0.21. And by the way, I want you to keep these to 4 decimal places, and I like you to truncate. So this is going to be 4.7619, 4.7619. And all I did on the calculator, just so you can see me do it, is I just went 1 divided by 0.21. That's all I did, nothing fancy, okay? And all I did was cut it off. I don't round, I just cut it off. What's the probability that the first person with antibodies in their system is the 6th person tested? Well, we said first, so that lets me know it's a geo. This right here is a singular value. So this tells me, all right, we're looking for a geometric PDF. All right, so I'm going to go to the calculator, and I go second vars, and I scroll and I see geometric PDF. And press enter, and it goes, oh, the first thing I need is my probability. All right, well, we know that the probability is 0.21, so 0.21, and the x value. Well, in this case, our x value is 6. So for my work shown, I need to see 0.21 and 6. And I end up getting 0.0646. And that would be adequate work shown. All right, that's adequate work shown, what I have here. Well, once again, the word first tells me it's a geometric. The fact that it's a specific value lets me know that it's working with a PDF. Next one, out of 15 people. So once again, we have a group. So since I have a group, this is probably going to be a binom. This, not sure yet, but probably a binom. What's the probability that exactly 3 have antibodies? Once again, I have a specific singular value. Matter of fact, if I were to make a number line 0, 1, 2, 3, 4, dot, 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 all the way up to 15, I'm only circling one value. If I'm only circling one value, that's a PDF. So this is a binom PDF. And what does the calculator ask me for? Second vars, binomial PDF. It asked me for my trials. Oh, it was out of 15 people, so I have 15 trials. The next thing it asked me for was the probability, which we know is 0.21, so I need to get that down. And my x value, I want to have exactly 3. So this is what should be in the calculator. All right, and that's your work shown right there. Your worksheet should always look just like that. And I end up getting 0.2489. Now I know you want to round, but I don't want you to. I want you to just go ahead and always truncate at 4. In other words, go 4 decimal places and cut it off. Don't need to round up or down, just go 4 decimal places and cut it off. Next question. What is the probability that the first person with antibodies is among the first 6 who were tested? Once again, we're looking for first. This tells me we have a geo. Here we have among. Because among is there, that means we have multiple values. It could be the first person, the second person, the third person, all the way up to the 6th person. So multiple values tells me it's a CDF. All right, so I'm going to scroll and see what the calculator asked me for. Second vars, geometric, CDF. Probability is asking for probability, and it's asking for the x value. But we know the probability is 0.21, and it has to happen among the first 6. So 0.21 and 6. This gives me 0.7569. Again, we just truncate. We just go to the 4 decimal places and cut it off. And rerun that real quickly. Second vars, geometric CD, oops. 0.21, 7569. Great. Next one, out of 12 people. So here we have a group. Because we have a group or a set, this is probably going to be a binomial. What is the probability that no more than 3? Okay, so whenever we have a binomial, I like to make a list of possible outcomes, ... all the way to 15. No more than 3 means it could be 0, 1, 2, or 3. I'm circling multiple values, so this makes this a CDF. So let's see what the calculator asked for. So second vars, binomial, CDF. It asks for my trials, it asks for my probability, and asks for my X. Well, my trials in this case was 12 because it's out of 12. The probability has been 0.21 the whole time, and no more than 3. Well, 3 is the highest value I circled. Since it's the highest value I circled, that's what goes in there. So I should have 12.21. My X value is 3. Does this match? It does, so it looks pretty good. And I end up getting 0.7673. 0.7673. The next one, out of 12. Again, I have that out of phrase, and I have a specific, and I have a group. If I have a group, it's probably a binomial. What's the probability that less than 3? 0, 1, 2, 3, 4, ... all the way to 15. Less than 3 means 0, 1, and 2. Well, I have multiple values. So anytime I have multiple values, that makes it a CDF. My trials is 12. My probability is 0.21. And the highest value I circled was 2. So my X value is 2. So let's see if we get that in the calculator. So second vars, binomial, CDF, trials is 12.21, X value is 2. And I end up getting 0.5231. Once again, I truncated. Always go to the 4 decimal places and write it down and cut it off. So 0.5231. Next one, what is the probability that more than 3 out of 10? So we have a group. Because we have a group, this lets me know we're working with a binomial. I make my little number line, 0, 1, 2, 3, 4, ... all the way to 15. So more than 3 means it could be 4 all the way 4 to 15. All right, so I have multiple values circled, so this is a CDF. Now, 0 is not circled. If 0 is not circled, I need to do a 1 minus, and I have to be very, very careful about this. All right, so this is a 1 minus. When we know my group or my number of trials is 10, we know my probability is 0.21. That part's all good. We like that. But now I have to be very, very careful about my X value. Because 0 is not circled, or because this is a 1 minus, my X value is the highest value that is not circled. All right, the highest value that is not circled, which happens to be a 3. All right. So anytime it's a 1 minus, I'm looking for the highest value not circled. So 1 minus second vars, binomial, CDF, trials, we said were 10. My probability, 0.21. My highest value that wasn't circled is a 3, so that's my X. And so I should have 1 minus binomial CDF. These two things should match right here, and they do. right? Press enter, and I get 0.1391. Moving on to the next page. What is the chance that at least 3 test positive from a group of 10? Once again, we have a group. So this tells me we're looking for a binomial. Anytime I see the word at least, I know it's going to be 1 minus. Everything else I'm not so sure about. I see at least, it's 1 minus. I'm going to make my list. 0, 1, 2, 3, 4, ... all the way to 15. At least 3 means it includes 3. All right? So, trials, 10, probability, 0.21. Highest value that's not circled, because 0 is not included, so the highest value not circled is 2, so this becomes my x. So 1 minus second vars. You know what? I'm going to clear my screen. Sorry. 1 minus second vars. Binomial. Cdf. Trials is 10. Probability is 0.21. The highest value not circled was 2. All right? Highest value not circled is 2. So once again, these things should match right here. Press enter. And we end up getting 0.3525. Somehow or another, that's not what I have on my screen, which makes me think I need to run this again real quickly. So 0.3525. Let me do that real quickly. One minus second vars, binomial, CDF, trials is 10, probability is 0.21, x value is 2. That all looks good. 0.3525. Great. All right, so that concludes that video. By the way, what I did here is the way you need to show your work on all your assignments.